Hi again, welcome back. So in last section, we learned about the metrics that we need to look at when we're analyzing the page loading experience. Those moments that matter to the perceived user experience when you're actually loading a web page. Now that we know those metrics, we can move on to the tools. And this is the fun part. This is the day-to-day work of performance, where we're actually analyzing how pages load and really deeply looking into what's going on. What's causing this particular metric to be slower than we would expect? So once we learn how to use those tools, we can then learn to set goals and budgets and then be able to monitor our sites to make sure that we don't regress. So this section will be all about those tools. Let's get started. All right, so the first tool that I want to talk about is web page test. This is probably the most important tool that you'll use when you're analyzing page performance. I'm going to just jump into the browser and we can start to use the tool in real time. All right then, so this is web page test. You can get there by going to webpagetest.org, and this is the home page, which actually, unlike a lot of other apps out there, doubles as the starting point for using the tool itself, in addition to a little upfront information to describe what the tool does. So where I typically start is to scroll down to this form where you can start to see the different types of tests that you can run. Site performance test is sort of a broad diagnostic, and that's the default. Core Web Vitals and Lighthouse and visual comparison and trace route are some other options. So just below that, we've got this input, and this is where you can start by inputting the URL that you want to test. For example, I could do newyorktimes.com to get the homepage of New York Times, any site that you want. And then further down, we've got some configurations that the web page test team, again, which I'm one of the members of, has deemed to be a good starting point. So these are some presets that give you a taste of the sort of configuration options that web page test gives you. And one of the big strengths of using web page test is that it works in different regions around the world. So these are actual different servers that are pulling up browsers in different actual physical locations throughout the world. And they either emulate or use different types of OSs and browsers as well. So different combinations of device types. For example, Chrome is really common, and many other performance tools focus on Chrome, for example, Lighthouse. Whereas in web page test, you can test other browsers like Edge, Firefox, and even more if we get into our advanced settings. Before I move on to those advanced settings, I just wanted to cover a couple things here. We've got whether or not you want to include a repeat view when you test this site. And what that does is it'll load the site once, and then it will also load it again on the same machine to allow you to test the caching configuration and see how the site loads differently for follow-up page views. And additionally, with any kind of test, including this default site performance test, you can include a Lighthouse audit along with it. So if you just wanted to run one of these, you could click Start Test, and I'll do that in a new tab here and get that test going. As a test is running, you'll get this little loading screen that tells you the configuration and a little bit of information about the queue, how many other tests are running, things like that. If there happens to be a pretty big queue on a particular location or device, you can try a different one, either through these presets or moving down, we've got this advanced configuration where this is sort of where you get into the power tool features of web page test beyond just the presets of the simple configuration. So once again, we've got different test locations that default ran from Virginia, but we have several in North America as well as other continents throughout the world. Look at all these options. These are all available to you for free. So that's a really great thing about web page test. It's been around a long time, and it is open source, and through webpagetest.org you get the features of the open source tooling, and optionally can pay for additional features that are offered through just the web service. And I'll get to those in a bit. Before I get into advanced features too far, I will take a look over here at our test result to see what you get after running a test. So here we have some information. We have a deep link to this result that you can share. This is public to anyone who has the URL, but it's not published otherwise on web page test. And we can see some information about when the test was run, the site that was being tested, and then the browser configuration location. If there are additional settings that you passed in, they'll all show up in this More menu. And then, you've got some options to share your test result, things like that. So beyond that, we can dig into some information about how the test went. And to start, we've got this little summary of observations that web page test will provide. And these are based on some diagnostics that it runs. And this is a pretty new feature. It comes from a new feature called Opportunities and Experiments. And this section here gives you a little summary of just sort of an overview of how we thought the page did from the perspective of a few categories, and those are quickness, usability, and resilience. So in this case with the New York Times, that was the site I tested. It says this site was quick to connect and deliver initial code. It began rendering content with little delay. The LCP metric was a little slow. Okay, so on and so forth with these other categories. We'll dig into those in a second, but if we scroll down a little further, we can see those metrics that we talked about last chapter. So again, our first byte time, our start render time, which I talked about as our first paint. It's the same sort of metric moment. Then we've got FCP. So first contentful paint, speed index, which is a metric that originated on web page tests long ago, and it's sort of a calculated time that represents the feeling of the speed of how the site loaded. LCP, after that, we can see it's orange, so that means it's a little high according to Google's criteria in Core Web Vitals. We've got CLS, which is not 0. It's a little higher than 0, but still green, so that's good. That means that layout shifts while the page was loading were pretty minimal. And then we've got total blocking time, almost 10 seconds. That's in red, showing that there's some improvement needed there. Locking up the main thread for almost 10 seconds is going to cause some problems for users on this particular type of device. In this case, we're emulating a average Android device. And then lastly, we've got the total bytes, which here is pretty heavy. New York Times, in this case, 17 megabytes in this case. So, I think that's more and more common, as we noted earlier, that especially news sites have a lot of auto-playing video, and also increasingly a lot of JavaScript. We can dig into the results here and see what contributes exactly in a bit. So further down this page, just after the metrics, we have this film strip, which is all white, but you can see as we scroll, you get an actual visual of the page as it loads in little keyframes. These are actual screenshots, in this case, every 100 milliseconds as the page loads. So that's pretty neat. And you can actually dig into that. If you click it, it'll go to this film strip view where you can see it larger. So very neat. I'm going to go back to that. So go back to the summary here. We'll get to the film strip view in a bit. But that's a little preview of it on the summary page. Then we have some real user measurements. So these are comparisons that were provided to web page test from the Chrome user experience report. Many sites that that you test in web page test will have information that we can reveal here about how Chrome has reported the user experience in real time of this particular site. So the Chrome browser has this built into it where those metrics can be recorded as users browse around the web, and they're stored in an anonymous way, and Google offers them here. So we can see in this case, it's a nice little way to compare how performance overall is reported by Chrome for all users of this particular site. So you can compare it with this synthetic test that we ran and see how close web page test is to the experience that Chrome reports. Unfortunately, that's Chrome only, so these sort of measurements that we get from Chrome User Experience Report are only going to be comparable to tests that were run in Chrome, but this one happened to be. And then as we scroll down a little further, we get to information about the individual runs. So when I did a default run on this particular site, I chose 3 test runs. And generally, that's probably the minimum number of runs that you want to do on a test, just because we're dealing with a live website, and sometimes network conditions can vary in ways that are inaccurate. So web page test runs several runs depending on how many you want, and it will pick the median test result based on speed index by default to show you up top for these numbers. And you can change that that metric that it uses the median for to see if a different run happens to be the median result for different metrics, but it defaults to speed index. And so I can see up here that was actually run number 2. So I could scroll down, and this is some details about run number 2. And if I click this image, which is really tall and shows all of the requests that particular page makes, it will take me to the details page. And the details page is nice, particularly because, well, for one, it's information about that particular test run. So you're on the summary, you're looking at the median run, but on the details view, you can see any run that you'd like, and those are linked up here. But the nicest part, I think, about the details view is that you have the waterfall down here, and this waterfall is interactive. Now, a waterfall is something that you'll see in many performance tools, like in browser dev tools, for example. Those have a waterfall. What you see as you scroll down these rows on the left are requests that the browser made when it was rendering and loading this page. And these are different types of requests, and you can see that this color coding up here talks about the different file types. So HTML is in blue, JavaScript in orange, CSS in green, and so on and so on. And there are also markers for moments, connection moments, for example. So like green is the point at which a request is making its DNS connection. The orange is connecting to the server. SSL step is in purple. And those all show up particularly on requests that are to a domain that hasn't been used yet. Otherwise, you can skip those connection steps, and you can see a lot of requests down here don't need them anymore because we've already connected to those domains. Lastly, we've got in pink JavaScript execution, and you can see it's kind of a pink-purple, but you can see moments where certain files flare up a little JavaScript execution where they're where they're threatening to block the main thread. If you go all the way down, you can see a little bit more information about the main thread. This last row here, or second to last, with the browser main thread, you can see color coding of various types of resources that were taking up the main thread at those particular times. And then you could see, oh wow, it's quite pegged here. There's a long task in red, so you can go up and see what's taking place there. Looks like, this particular script has a lot of JavaScript execution going on almost a whole second, and start to debug that way. If you scroll back up, for each line in this interactive waterfall, we can click it and find details about that request. And this is where you find out things like, information about when the request connection started and ended and started downloading, how much CPU time it spent, how many bytes that resource was when it downloaded versus how many bytes it was when it decompressed after delivery, things like that. And then you can see things like the headers for the request. In this case, we're looking at the first HTML document, and then various information in there. If I look at row 2 here, we have a little indicator next to it that has this orange X, and that shows that that particular request blocked render. So in this case, we have a couple of CSS files that were requested in such a way that render was blocked. So that's something we could dig into in a little bit and see maybe there's a way that that could be requested differently. Maybe one of these CSS files is not necessarily critical and could be loaded asynchronously, for example. So that's great information to see right in the waterfall there. And then I should mention that up here we have color-coded lines representing different metrics as they appear in the waterfall. So you can see them lined up with times of when requests happen to load. So things like start render, first contentful paint, LCP is a green dotted line. You can see those here right around 3 seconds in the timeline. And then there are others like, there was a little layout shift right around 20 seconds. DOM interactive, when the DOM became interactive, was almost at 11 seconds. And we saw that reflected in our metrics above, where it mentioned an almost 10-second long total blocking time. So that's how you use a waterfall. It's extremely useful. I should also mention that for each of these colors for the types of files that are being requested, there are light and dark colors for each one, and those represent request versus download time. So requesting the HTML versus downloading it, and you can see those appear here. So that's the details view. And then there are many other views. I showed a little bit of the film strip. One thing that I should highlight in the film strip that's pretty neat that I didn't show before is, now that you know what a waterfall is, there's a non-interactive version of the waterfall below the film strip view. And if you look at this little red loop kind of line over on the left here, there's also one over the waterfall. And as you scroll the film strip, that loop moves on the waterfall. So you can see the moment represented right here on the film strip, also in the waterfall. So really, really useful if you're trying to line up, why is there a big layout shift right here? Then I can look down and start to figure out what file happened to finish downloading and executing right around then. So it's easy to start debugging from there. You can get information about your core web vitals, specifically here. This is some of the metrics that were shown in the summary page, but they're actually in a lot more detail on this view. For example, if you wanted to learn more about why your LCP time is 3 seconds, you can go to this Web Vitals page and actually see what the LCP element is, and in this case it's text. So maybe you might start to consider, well, why is the text taking a little while to finish loading? Maybe it's a custom font, for example, that was finishing painting right there, something like that. And so on for all the other metrics in the Core Web Vitals on this page. For example, CLS here, you can actually watch, as you hover over this image, you can watch the layout shift in real time and find out what changed to cause that layout shift. And if they had just reserved a little more room vertically for that date line to come in, then they would not have a CLS above 0. So that's really useful to look at. Moving on, there are several other pages here. I'm not going to go into every single one. Some of these talk about the optimization of your files, whether or not your images are optimized fully, how your content delivery breaks down, how much of your, well, I guess I could show that one. We were curious about what percentage of this 17 megabyte page was video, for example. And just as I predicted, video is shown in green here, and over 50% of the page weight is in video bytes. The rest, 34%, most of the rest is in images, and then of course JavaScript. So that's the bulk of it. It says here in JavaScript we've got almost 2 megabytes, so that's quite a lot. That's the transfer size. So more and more we're seeing that on modern sites, right? Furthermore, we have some links out to other services. Cloudinary can analyze your images. Request Map, which I showed earlier, can talk about third-party requests and how they spider out. This data cost link shows Tim Cadleck's what does my site cost site for this particular test result, and then a security score, which goes out to Sneak. So really neat. So from there, I wanted to highlight a new section of web page test as of this year. That's called Opportunities and Experiments, and we sort of saw the summary of this section on the homepage. But if you click through those little summaries about how the page loaded, you get to this page, Opportunities and Experiments. And again, it's broken into these categories of quickness, usability, and resilience. But as you expand into each section, as you scroll, it shows the particular diagnostic checks that were run and whether or not things looked pretty good. And in that case would be you'd see a green check mark. Or if Web Page Test found some opportunities for improvement. And if it did, then you'll see this orange-red sort of exclamation point, noting that there's something you might want to take a look at. So in this case, the tool found that there were 7 CSS files that are blocking page rendering. So that's useful to know. And we saw some of those in the waterfall view. These in particular were the first 2 and 3 requests on the waterfall, I believe. Then there were some later on as well. So those are some requests that could potentially be optimized. Delivery of those requests could be optimized in such a way that they could free up the page to render sooner. So that's pretty nice. For each of these opportunities, the Web Page Test tool recommends either tips or experiments. And in this case, we have a couple of experiments. In this case, the experiments that it suggests trying have to do with these assets above, and they say you could either inline those CSS files, maybe not all of them because it would start to bloat your page, but maybe 1 or 2 would make sense to inline, or load them asynchronously. It's another approach that it recommends. Notably, experiments are one of the paid features that Web Page Tests offers as part of its Pro plan. So I'm just going to log in real quick. Okay, and now that I'm logged in, we can see that these experiments are enabled, and if I want to run one or more of these, I can simply check the box, and these run without having to write any code. So the way these run, there's actually a proxy that Web Page Test offers, so it can change it in flight, in real time, but it's not actually changing your live site. It's just making little changes that pass through its proxy. So for example, if I were to say inline all of these CSS files, Web Page Test would rerun this test, and as the HTML gets passed through the experiments proxy, it will find references to those CSS files and replace them with style elements with the contents of that CSS embedded right into the HTML. And again, we'll get into that technique in the next chapter when we're talking about making things faster. It's not always necessarily going to be a performance improver. Sometimes it will actually degrade performance, so you have to kind of experiment with these things. But you can see the sort of power that this enables without having to run code. Other types of experiments that are offered in this are notice that LCP was high. We saw that it was about 3 seconds. In this case, it doesn't have a experiment to recommend. The LCP is text, so it says look for ways to get your text rendering to happen sooner, such as loading your fonts in a more optimized way. For example, if LCP was an image, it might recommend ways to preload that image, for example, or request it at a higher priority. So that's sort of this page. Once again, the opportunities are free. So as anyone wants to use this, they can, and they'll get tips and observations about things that might be slowing down a site. And then if you happen to have a pro account, you can run experiments. You can even create your own at the bottom. This is pretty neat, where you can arbitrarily add HTML to the site being requested, maybe at the start of the head of the page, or at the end of the head, or at the end of the body. You can find and replace text, like whatever you want in the page, whether it's HTML or even replace a headline with a different headline. So lots of things. Also, all the experiments that are offered up top in a more reactive way are available down below in a manual way under the Create section. So that's really neat. So if I go back, now that we've covered that, I just wanted to look over the advanced settings a little bit. Like I said, when you're starting a test, you can choose different locations around the world. You can also choose different browsers. There's Firefox. There are even some iOS devices in there, so you can test on a Mac. You can test iOS, Safari. Further down, we have test settings, so you can actually change the connection speed to different common connections like 4G or 3G or a cable connection, which is really useful. The browser dimensions, the number of tests to run. 3 tends to be the default that we have for our presets, but you can always do more than that. Generally, as a rule, we say the more tests you do, the more likely that you're going to get a high quality median run because all the outliers are kicked out. Once again, you can choose between first view or first and repeat view. Capture video is great because that lets you see the timeline in that film strip. And check this out. If I go to that film strip view, I can go under the settings, and if I want to see a video of the page by clicking this down here, and this will actually give me a downloadable video. Again, this is free, part of the free tool that shows with a timer the page loading in real time. So moving on, you can also set the label of your test. So if you want to describe it in such a way that it's easy to find in your test history, that's really useful to use. Under advanced settings, there are lots of things in here. I won't go into every one, but a couple useful ones to know. Preserve original user agent string. Some sites may end up with a time to first byte that's really high, for example, and something looks off. If you ever see that, Web Page Test will actually recommend that you check this box, which actually takes information about Web Page Test out of the browser's user agent string so that it doesn't look like it's coming from a bot like Web Page Test. And usually that's not important, but for some servers, they're configured to artificially slow down their delivery to bots. So if you want to check that one before running your test, that can help. There are also some custom options for running Chrome if your test is on Chrome. You can even script the browser to enable flags for different Chrome-only features. You can run extensions. There's so much in here. Scripting is really neat. You'll have to read the documentation here about it, but scripts actually let you drive web page test from commands like, for example, go to this particular page, find this element in the page, maybe it's a button, click that button, go to this next page, record the performance of that page. So you get like multiple step performance readings, which are really useful, for example, in sites that use single page app architecture, for example. So you could, for example, tell Web Page Test not to listen for a minute and go to the home page of a single page app and start listening at that point, and then click one of the navigation items and then stop listening when the next page loads. And that would give you a way to measure the metrics of how long it takes to change pages on a single page app. So really neat. There are also some options for blocking requests. So you can tell Web Page Test to just simply fail immediately if requests to particular URLs are made by the browser. And that's really useful for testing resilience. You can also test a single point of failure on any domains that your site requests, which is really useful, again, if you want to test for resilience of, for example, maybe your JavaScript files are hosted on a third-party service and you want to see if your site can handle that service going down. And that happens all the time with sites around the internet. So really useful to be able to test things like that. All right, so that's pretty much it for Web Page Test. Again, that's webpagetest.org, and we'll move on to our next tool. If you want a really good recap of all of the points that I just covered, I really highly recommend checking out in the resources at the end of this section, this blog post by newshoe.github.io. It talks about the Web Page Test waterfall and really digs into all the features that I just covered at an even deeper level than I went over it. So check that out. So the second big tool that I want to cover is Page Speed Insights. This is a tool that Google offers, and it's a little different than Web Page Test in that it gives recommendations on how you can improve the problems that you're experiencing. So it's a little more consumer friendly than Web Page Test. Let's just look at it in the browser. Okay, so here we are in the browser at PageSpeed Insights. That's pagespeed.web.dev. And just like Web Page Test, it starts by offering a field for you to enter a URL. In this case, that's really all you get. So I will start by putting in the New York Times again, just so we can see the differences. I think it's really critical that you use different tools when you're testing performance. It's good to get a neutral perspective across different tools when you're figuring out the bottlenecks that are impacting your site. So when we get a result on PageSpeed Insights, the first thing that we see are some of the metrics up top. They're split into mobile and desktop, and we see some of the core web vitals up top, LCP, FID, CLS, all the things we covered before. And up here we can see that according to their assessment, it passed core web vitals. Once again, core web vitals is a a factor for search page rank, for example. So companies are really interested in getting those passing scores on that metric. Whereas on the desktop, it looks like the New York Times is failing their Core Web Vitals assessment. So you can dig in to figure out what it is. It looks like CLS is a little too high at 0.16. So they would need to work on that. Whereas on mobile, everything is in the right range. As you scroll down a little bit, you get a screenshot, a performance score, and more metrics. Non-Core Web Vitals in this case, FCP, time to interactive, blocking time, all these. You have a timeline view as well, like the film strip in Web Page Test. This one is a little less configurable than you get in Web Page Test, but it's a nice glance at how the page loaded. And then as you scroll down, you get opportunities again, and you can read about some of the suggestions that PageSpeed Insights makes about changes you could make to make your site perform better based on various metrics. And it's really nice how you can flip between audits that are relevant to particular metrics here. So if I wanted to see just suggestions that'll improve my first contentful paint, I've got one here that says eliminate render blocking resources and the particular resources that it noticed were render blocking. Interestingly, those are different than the 7 that Web Page Test caught. So again, super critical to use different tools and just see some balanced feedback on your site. So that's PageSpeed Insights, and it runs on Lighthouse behind the scenes, which is available in various tools, including in the browser's dev tools. All right, another set of tools that maybe you're already familiar with, at least for inspecting other parts of your development process, the browser dev tools. All of the major browsers today have fantastic developer tools that are built into them. So I'm just going to open up a few of the popular browsers and go into their dev tools and just look around a little bit and see how things apply to performance analysis. Okay, so first up, we have Firefox, and you can open Firefox DevTools with Option Command I. That's sort of the universal command across Mac browsers for browser DevTools. And when you open them up, you get a little drawer at the bottom here, and the first thing you're going to see is the inspector, and this is where you can inspect the DOM to see all of the HTML as it is rendered live. So this is after JavaScript has manipulated the DOM. So it could be different than the page source. And if you want the page source, you can right-click the page and view page source and see it as it was delivered. So the inspector is really handy because you can click on elements here and see the CSS that's applied to them. This is beyond the scope of this particular lecture. And I'll go over here to the Performance tab, and this is really handy. The Performance tab, as you can see, is very focused on tasks that the browser is running at the time. So this is very useful when you're analyzing how a page is performing once assets start to be parsed. Is the browser working too hard? Are the paints taking too long? So that's the tab you can look at if you are curious about why your application feels laggy after it loads. But since this lecture is mostly about the delivery process, let's look at the Network tab. And this is very similar to what you saw in Web Page Test with the waterfall. You can click any of these requests and get more information about their headers, their cookies, their timing. All of that stuff is all here. So that's Firefox DevTools. If I were to open Chrome, you can see a very similar experience. We've seen a great deal of normalization across browser tools. If you're used to using Firefox, you can jump over to Chrome and pretty quickly get a handle on where things are. And once you're in those dev tools, I mentioned Lighthouse earlier for a tool that integrates with PageSpeed Insights. Well, it also integrates with Chrome's developer tools. And the great thing about that is it works locally. So you can actually analyze the pages that you're working on before you push them to a staging or a development server where a tool like Web Page Test or PageSpeed Insights would be able to see it. So I'll just show you how this works. If you're in DevTools, you can go to the Audits tab, not the Performance tab, but the Audits tab, and click that little link that I clicked for Generate Report. And this will actually spin up a little Lighthouse overview of the page that you're running. It'll even do it locally again. So this is really nice as an alternative to PageSpeed Insights, which would run Lighthouse, but it's not local. So you would need a URL to go to. This could work on localhost. So as you can see, it gives you some stats as it's working. And just like PageSpeed Insights, you get the score for performance, but you also get other categories like accessibility and general best practices for usability, SEO, and whether or not it's a progressive web app. So you get a lot more out of Lighthouse running it like this than you would in PageSpeed Insights. Another one of my favorite tools is Browser Stack. What it does is give you access to all of these browser and device combinations that you can test live. So you're actually pulling up a live device and looking at it, and you're interacting with it. So it's not just screenshots, right, of how your website looks on that device. You can actually feel the performance, and these are real devices, not just simulators. Got some of these kicking around? Maybe an old iPhone or an Android or a Windows phone. In addition to Browser Stack and tools like that where you can test devices from afar, it's really nice to be able to test a physical device right in your hand to get a sense of how the page is actually performing. Does it lag when you interact with it? You can sort of get a sense of that when you use tools like Browser Stack, because those are real devices too, but there's nothing quite like using a real device and feeling the pain of interacting with a site on a low end or average really device. So when you're using a device like this, a lot of them are able to be profiled in your browser dev tools if you just plug this device in through a USB cable. And I'm showing right now a couple of examples on how to do that, both in Android and iOS devices. So you can find those in the resources for this chapter. All right, so we talked about the tools and really dug into how to identify metrics and problems in your page loading process. Next, we can move on to setting goals and creating performance budgets. And those are two subtly different things that are both very useful in their own right. Goals, of course, are where you would like to be with your performance, maybe for particular metrics or just overall improvements. Whereas budgets can be thought of as sort of like the worst performance that is acceptable for your site. So you don't want to regress past the budget that you've set. So let's look at a few posts on each of those. So how do you know how to define performance goals? You might see many areas to improve, but what should you focus on? Well, one thing we like to do where I work is to start with some competitor analysis. Run your site up against your competitors and mark your timings. So this is an example of that. It's 2 site timelines that we did in web page test, and we marked them up to show where competitors are doing better than our client, and that gives us something to work with. Another way is to use statistics about performance and user patterns. So again, like this one that I showed early in the lecture, Google found that 53% of visitors abandon sites if they have to wait more than 3 seconds for content to show up. So if your site is taking longer than 3 seconds on an average connection, that's a goal to work on. So you can use statistics like that to set your goals as well. And once you have those goals, you can describe those on the same sort of timelines that you would use to analyze a site. And that's really useful in, say, a presentation to your clients or even to your colleagues. Here's one that we did for a client project where we recommended to get their first contentful paint under 2 seconds on a faster connection on mobile devices. So that's really handy. You start to set goals like that. But budgets, on the other hand, are a little different. Like any budget, in web performance, a budget describes the most you can afford. In this case, the budget isn't defined in money, but in loading time, in page weight, in user input delay, things like that. It's not a goal. The goal is to spend less of our budget. In this post by Tim Cadleck, I think he describes it really well. He says, a performance budget is just what it sounds like. You set a budget on your page and you do not allow the page to exceed that. This may be a specific load time or another metric that you're trying to hit, but it's usually an easier conversation to have when you break the budget down into number of requests or the size of the page, things like that. And I love this post by Harry Roberts at CSS Wizardry as well. He clearly separates the idea of budgets nicely by saying, our budget for any metric is to never be worse than it is right now. So that's a really good way to think about budgets for an existing site, right? So it's not a goal, it's sort of the worst case that you can tolerate. But predefined budgets help too at the start of a project. Even if they're arbitrary a little bit, it's still helpful to have something to start with to inform your progress from then on. I added this post from Mark Perkins of ClearLeft, which is a great agency in the UK, that talks about performance budgets as a step in the early stages of a process and how that's different, how to think about it differently when you're setting a budget for the first time on a project. And what I like most about that post is that Mark defines a budget as sort of a talking point to make sure that everyone on the team understands that decisions during the design process have consequences for performance. All right, so the most important thing about setting goals and setting budgets is actually following through on them and monitoring them. So next, I'll cover some of the tools that we use to make sure that we are keeping track of these goals and budgets that we set. There are really good tools to help us monitor and communicate problems and speed regressions across our teams today. For developers, especially working on the source of a site, tools like Lighthouse can actually integrate right into GitHub where our code lives. So we can test changes as we build sites and stop regressions before they go live. So something like a pull request can end up resulting in a build failure because one of our performance budget items didn't pass. That's really helpful to know right in the moment. Unfortunately, tools like Lighthouse are really developer focused, and they don't really get at the sort of performance regressions that are caused by the greater team, such as when, say, third-party widgets are added to the code base and the live site regresses. So they're not that great for that. But other tools can do that for us really well, and SpeedCurve is one of those. In SpeedCurve, you're presented with a dashboard full of budget numbers and reasonable ways to set them. And whenever you regress, you're notified, so the whole team knows when something's not working right. Another tool is Calibre. And Calibre has a lot of similar features with the dashboards and the budgets. One thing that it does in particular is previewing how your site would act if ads and third-party trackers and things like that were blocked. And that's useful for a couple of reasons. First, it's reasonable to keep up with how your site actually looks for a lot of your users who have ad blockers and other things like that. Even browsers have this built in now, so it's good to know how your site's really behaving. But also, it gives you a really clear way of communicating the cost of the third parties that you add to your site. And maybe the cost of one of those is too much and you decide to remove it. Which brings me to the final point of performance budgeting, which is, what if a change breaks the budget? Well, first you can look at optimizing those features or changes. A second thing you can do is to remove the change that you made, or decide not to add it in the first place if it's something that you're debating adding to the site. So you have these options when you have a budget in place. You have something to talk about, and that's what's most important. All right, so in this section, we covered the nitty-gritty of using the tools to analyze the metrics of a page loading process. Then we went into performance budgets and setting goals and how to codify those budgets and goals with monitoring tools. Familiarity with all of these tools is really important. So before moving on to the next section, I'd actually suggest that you play with some of these tools to really get comfortable on your own with all of the features they have. So here are some recommendations for how I would do that. You could audit some sites that you're working on now, or really any site on the web. So open them up in web page test, page speed insights. And then for those sites that you're working on, identify the critical performance problems. Try to analyze all that's going on and figure out the highest priority things that you should be working on to improve performance immediately.